and that makes this the conjugate acid pair. Okay, next one, CH3COH, which we've now learned is acetic or ethanoic acid, which is a weak acid. To become the acetate ion, in other words, CH3CO minus, it would have to lose this hydrogen. In order to lose a hydrogen, you need to act as an acid. Then that forms your base. Then water, in order to become hydronium, water has two hydrogens. It needs to become 3, so it needs to gain a hydrogen. If it gains a hydrogen, it is a base, and that becomes your acid. Okay, then moving on to the last one we'll do together, NH3 becomes NH4. For NH3 to become NH4, it needs to gain a hydrogen. And again, let's keep that definition in front of us. Okay, there's our definition at the top. So NH3 to become NH4 needs to gain a hydrogen, and that makes it a base. Let's keep it as base 1 rather. And then that would form acid 1. And HCl to become Cl, HCl would have to give off a hydrogen, that makes it an acid, and that becomes a base. Now, if you scroll to later on in that worksheet, it ends up giving you a table of you having to fill in conjugate bases and acids. Now, I want to do a couple of these with you because it's important that you know how to just come up with the base or the acid without having a whole reaction. Okay, so let's write down the little definition again. Acids are things that give off hydrogen ions, and bases are things that gain hydrogen ions. Okay, now keep that in mind. I'm especially going to pay attention to the charges here. So H2PO4 minus 1 is dihydrogen phosphate. It's a compound ion. Now, if you want the conjugate base, that makes this the acid, which they've made quite clear in the table. Acids are things that give off hydrogen. So if this gives off hydrogen, it needs to end up with just one hydrogen and then PO4. Now, when things give off hydrogen, hydrogen's got a +1 charge. Their charge needs to become one more negative. Now, this is already -1. So it needs to become -1 minus another 1, so -2. The next one is HPO4 minus. So it needs to give off a hydrogen. So it becomes PO4. It's already 2 minus, so now it becomes 3 minus. -3 or 3 minus, doesn't matter how you write that. Okay, let's skip to another one here. Okay, because like I said, these were in the live worksheets, so we're just going over a couple of them to make sure we understand. So the next one, CH3COH, we know is a weak acid. If it gives off hydrogen, and you have to kind of learn this one, you have to learn that it's the last hydrogen it gives off, not one of the 3 here in front. It's always this one. So it becomes CH3COO. Now, when you act as an acid, and become a base, you need to become one less or one more negative rather, so it becomes -1. Okay, then let's go to this one here, hydronium. So it starts off with 3 hydrogens, it needs to lose 1 and get only 2 hydrogens. Used to have a charge of +1, it needs to become 1 more negative, so now the charge is neutral. Now you don't have to write the 0 there. For the purpose of the live worksheets, I did ask you to put a 0 there, but in a test or something, please don't write the 0 there, it's not necessary. Okay, then let's look at some of these where they're giving you the base and they want the conjugate acid. So let's look at HCO3, for example, hydrogen carbonate. So if something is a base, it means it needs to gain hydrogen. So this has already got 1 hydrogen, so it will have to be 2 hydrogens, and then CO3. And then the charge is -1 at the moment. If it's a base, it needs to gain a H, which is +1, so it needs to plus a 1. So it needs to become 0. But again, in a test or something, you would not write the 0 there. Then let's go on to another one. Let's go on to NH3. So NH3 has already got 3 hydrogens. It's a base. It needs to gain a hydrogen and become NH4. The charge used to be 0, so you need to add 1, so it becomes +1. Let's look at PO4 minus. Okay, if it's a base, it gains a hydrogen. The charge is -3 at the moment. You need to +1 to that charge, and it needs to end up being -2. So we can make a little general rule that if something is an acid, the charge that it needs to become needs to be 1 more negative. So if it used to be -2, it now needs to be -3. If it used to be neutral, it's now -1. When something is a base and it becomes an acid, that base's charge needs to add 1 to it. So if it used to be minus 1, then you need to plus 1 to it, it becomes neutral. If it used to be minus 1, plus 1 to it. If it used to be minus 2, plus 1 to it, and it would become minus 1. Okay, so hydrogen has a positive charge, that's why it always adds plus 1 to the charge. Okay, then you need to know the definition. So if you haven't written down your book, write it right now, of an amphiolite. An amphiolite is a substance that can accept and donate protons, or it can act as an acid or a base. Okay, both those definitions are acceptable. So it's either a substance that can act as an acid or a base, or a substance that can donate or accept protons. Okay, so write that down if you don't have that already. Then you get a little list of possible amphiolites. But the easiest way to probably go about this is when you have a substance and you are, so oftentimes I'll give this as, for example, a multiple choice. And they'll ask you identify the list of amphiolites, and they'll give you a whole bunch. If you have a substance and it can go both ways, for example, if you had water and you ask yourself, what would water look like if it gained a hydrogen? And what would water look like if it lost a hydrogen? Do you recognize both those substances? Now, it does mean you need to know your compound ions well, as always. So yes, I do recognize that. So yes, water is an amphiolite. If I look at something like ammonia, can ammonia gain a hydrogen? Okay, becomes ammonium. If it lost a hydrogen, it becomes this. Now, is that anything you recognize? That's not anything I recognize, so no, that's not going to be an amphiolite. So this is not an amphiolite. Okay, let's look at a couple others. So that's the hydrogen carbonate ion. So if it gains a hydrogen, it becomes H2CO3. If it lost a hydrogen, it becomes CO3 minus 1, minus another one, which is minus 2. I recognize that, so yes, this is an amphiolite. So it's a substance that can act as an acid or a base. It's a substance that can gain a hydrogen and lose a hydrogen and become just one of your recognizable compounds or compound ions. Okay, which means, like I said, you need to know your compound ions very well. Okay, so in this case, you had to add a hydrogen and take away a hydrogen and figure out if that substance still exists. Okay, I'll leave this up for a second for you to write down. Okay, then we're going to move on to what was your live worksheet number 1, which is your acid-base reactions, which I think is a very important part of this section. So you can write the heading acid-base reactions. So the first thing here is you need to know your 5 rules. Okay, and this is literally something you'll need to memorize. If you don't know your rules, you will not be able to complete these reactions and balance them and do things with them. So the first rule is any acid plus a metal will give me a salt plus hydrogen. Now, as I do these rules, I'm going to do 2 or 3 examples of each, and then we're going to do a whole exercise at the end. So let's use one of our acids, and I'm going to try and use a different acid every time so we get used to them. So hydrochloric acid plus calcium gives me a salt. Now, you'll see from the live worksheets, the salt is the metal and the negative part of the acid. Now, I used to say the second part of the acid, but I'm careful of that because not every acid, their negative part is their second part. You'll see what I mean just now, okay? We know that H has got a +1 and Cl has got a minus charge. Now, we know metals always have a plus charge, so that's the reason that forms a salt. The positive metal will bond with the negative part, remember opposites attract, and it will become a salt. So your salt will be CaCl. Now, it's extremely important that you figure out the charges on each of those ions and then do your cross multiplying. So elements in group 1 have a charge of +1. Elements in group 2 have a charge of +2. Transition ones are different, except zinc you need to know is +2 and silver you need to know is +1. Group 3s have a charge of +3. Group 4s have a charge of plus or minus 4. Group 5s have a charge of -3. Group 6 -2. Group 7 -1. And group 8 are neutral. Okay, so if you look at this, calcium is in group 2. So calcium has a charge of +2. Chlorine is in group 7, so it's a charge of -1. If we cross multiply that, it gives me CaCl2 and then plus hydrogen. Now we've done balancing, and the reason we do balancing is for sections like this where we're actually now going to practically apply it and we need to now balance this reaction. So you have, let's start, my suggestion when you balance and there's oxygen involved, always leave oxygen till the end. In this case, it doesn't really make a difference because there's no oxygen. So let's start with H. You have one H on the left, 2 on the right. So I'm going to put a 2 in front here. Then you've got, now you have 2 Cl's on the left, and you've got 2 on the right, so that's perfect. You've got 1 Ca on the left, 1 C on the right, perfect, so that's balanced. Okay, then let's move on to another example. HNO3 plus lithium. Okay, so as I write these down, make sure that you're copying them into your book so that you have lots of examples. Then your next one, nitric acid plus lithium. So your salt is going to be your metal and the negative part of your acid. So it's going to be lithium nitrate. Okay, next time I see you, actually, we're going to do a little spot test on the compound ions, because if you do not know your compound ions, if you don't know that sulfate is SO4 2- and nitrate is NO3 -1, you are really going to battle with this section because the compound ions are everywhere in acids and bases. So lithium is a charge of +1, nitrate is a charge of -1. If you cross multiply, it stays LiNO3. So obviously this working out you'll have to do on a separate page or something. You can't do it as untidy as I've done here, and you'll just have to write the final product there. So let's just do that properly now. Okay, plus hydrogen. Now we need to balance. There is 1 hydrogen on the left and 2 on the right, so I need to put a 2 in front here. Then I'm going to leave the oxygen till the end. There's 1 lithium here, 1 lithium here, so that's fine. Then there are 2 nitrogens on the left, only 1 on the right, so let's put a 2 here. Then you have 2 times 3, 6 oxygens on the left. So 2 times 3, 6 oxygens. Okay, so everything balances out. Okay, then we go to rule number 2. Rule number 2 says an acid plus a metal oxide gives me a salt. And you can imagine there's more than just a metal here. There's now extra little oxygen. And that extra little oxygen combines with the hydrogen and forms water in this example. Okay, so let's do an example. Every time trying to use a different acid so we get used to all of them. So sulfuric acid plus, let's say, magnesium oxide will give me a salt and water. Now the salt, again, is your metal and the negative part of your acid. So your salt's going to be MgSO4, we'll cross multiply now, plus water. So Mg's charge is +2, sulfate's charge is -2. Again, so important to know your compound ions. If you cross multiply, it just gives you MgSO4. Remember the +2 and the -2 cancel out. You can write Mg2SO4 2, but then you have to divide by 2, and then you just end up with MgSO4. Okay, writing it like this is not acceptable. Okay, we have to divide by 2. Then let's look at our balancing. I've got 2 hydrogens on the left, 2 on the right. 1 sulfur on the left, 1 on the right. I'm going to leave oxygen till the end. 1 magnesium on the left, 1 on the right. 4 plus 1, 5 oxygens. 4 plus 1, 5 oxygens. Everything balances out. Sometimes it does balance out from the start. Okay, next one. Let's use carbonic acid, H2CO3, plus let's do lithium oxide. Okay, so in this case, you are going to form your salt with your metal as always and the second part of your acid. So it's going to be LiCO3 plus water. Let's cross multiply. This is +1, this is -2. So that 2